Hello and welcome to our special Digital Futures session today on structural craft. This is the first of a series that is hoping to occur annually, and it is a collaboration between Princeton Institute for International and Regional Studies and Hispleta, the Association for Brick Industry in Spain. And today's session is hosted by a special guest, Wesam Asali, and he will be coordinating and moderating the session between all of our speakers today. Digital Futures, as you know, will be hosting our summer events very soon, so please keep a lookout for those events and other future talks. And I would like to now welcome Wesam to take over and introduce our speakers and the event today.
Thank you so much, Virginia. Welcome, everyone. I will share my slides. Okay, can you see them? Can you see the slides? Okay, great. Welcome. Thank you very much, everyone, for being here. My name is Wesam Asali. I'm an architect, assistant professor at IE School for Architecture and Design. Welcome to our first panel of the series Structural Crafts, in which we aim to bridge between building crafts and structural design by discussing and exploring topics related to education, construction, and sustainability. In this first edition, we will be talking about tile vaulting and shell design. And we have with us here, first I will start with Professor Maria Garlock. She's a program director for the Architecture and Engineering program at Princeton University. Her research aims to bridge the gap between academia and practice, both as related to advancing the knowledge in structural engineering design and as related to the education of future engineers. We also have with us David Lopez. David, he's a professor at the School of Architecture at the Universitat Politécnica de Catalonia. He holds his PhD from ETH Zurich on the study of structural behavior and assessment methods of tile vaults. And he's also a co-founder of his architecture practice, Map 13. And finally, we have with us Robin Oval. He's a structural engineer. He did his PhD at École des Ponts in Paris and in ETH Zurich on typology finding of force and structural patterns. After that, he was at the University of Cambridge and now at Princeton University as a postdoc researcher at the Form Finding Lab, where he is looking into automation of construction and fabrication. And without further ado, I would like to make an introduction to the theme and somewhat the scene of this discussion. And I have 2 slides to share. And I know this is not a tile vault, but I think it conveys the purpose of what I want to say. In our teaching and discussions about structural design today, a simple tent structure is usually conceived through something similar to this, I would say, beautiful drawing. In fact, this drawing was made by Cabell for Bernard Rudowski's seminal book, Architecture Without Architects, which was published in 1964. Now, we note the main structural and architectural aspect of the tent through the drawing of the membrane, the poles, and the stakes. But what happened if we ask the same question of drawing a tent for those who inhabit and make these tents? We will not only get the notion of the structure, but also the cultural, architectural, and social meaning of the spaces that it's described by the structure. So, and I think it is okay to have an abstracted vision of phenomenon to understand how they work. But sometimes we forget how our knowledge as designers and engineers dwells in the making and inhabiting of the built environment. And with today's pressing issues of environmental and social impact of design, the skill to dialogue between making knowledge and design knowledge is very much needed. In this panel, we want to initiate these topics and to question the relationship between, for example, automation and crafts, between materials and labor, and between hand and digital fabrication, so that all can be equally important and operate in the same sphere. And to harness also the existing building culture and look for bottom-up approaches that learn and develop building crafts through technology. And with kind of this scene, I would like to introduce the craft that we're talking about today, which is thin tile vaulting. Thin tile vaulting, and I know David will talk more about this topic, is a craft of making vaults, which, as an opposed to masonry structure, traditional masonry structure, it uses tiles, lightweight tiles, and plaster of Paris. It is constructed through gluing those light tiles with a fast-sitting mortar, and therefore they require, in many instances, very little formwork. The technique is also known as Guastavino vaulting in the US, which referred to Rafael Guastavino, which took the construction technique to the US at the beginning of the 20th century, and Catalan vaulting as well. And in action, this is a small video of the master here, Salvador, who's mixing the plaster, and then he's using the mortar of the mixed plaster to start gluing the tiles to the wall and to each other. And once the first coursing is there, the second one starts to be built consequently. After a portion of the structure is built, more layers of tiles are added with normal cement now. Could be lime mortar traditionally, but also cement mortar. Tile vaulting is an ancient system with early evidence from the 11th and the 12th centuries. And the evidence show that it was concentrated in the western region of the Mediterranean, mixing techniques from North African and Roman architecture. And from this very brief, and I would say somewhat reductive timeline of the technique, we can notice how tile vault traveled across the Atlantic to the New World since the 18th century. But we also note, especially in this zone, how the technique has also expanded during the early industrialization of construction, where we found the technique being patented and used in locations such as Belgium and Germany. This movement of knowledge has produced beautiful and efficient structures. On the left, we have César Martinel's winery built near Barcelona, which is one of the late Catalan modernism architecture. And this winery, in fact, was built as a low-cost building. It was a cooperative winery. On the right, we have Luis Moya, Museo de América, which is located in Madrid, which has been also built, it has been built in the context of post-Civil War in Spain, where elements of reinforcement, such as the rib arches that we see here, were mixed with local making of vaulting for the infill. In more instances in the US, we have to the left, the Asheville Basilica, the San Lawrence Basilica, and to the right, the ballet school in Havana by Vittorio Garatti. And I think, Maria, you'll tell us a little bit more about this project. So what I want to note is that I've mentioned very expressive and beautiful structures, but the continuation of tile vaulting would have never been possible without the contribution of its craft community. Because the technique existed and exists in vernacular realm, the technique is able to move from utilitarian to expressive structures. And the construction of tile vaulted stairs in Spain, for example, gave rise recently to the reactivation of the technique in the many recent projects that we see in Spain, outside and inside Spain. And so the inclusion of the method and ways of making is very important to the development of both engineering and crafts mutually. So as a prompt of the panel, I want to ask, how can we use the technology to support and not replace builders? And in line with the UN 2030 agenda, with the Sustainable Development Goals that claims leaving no one behind, we want to ask how to move with a culture of building craft and not leave it behind us. And with these questions, I would like to start our presentations. And maybe, David, you can start your presentation now. Thank you all.
Thank you, Wesam. Thanks for your presentation, and thank you also for the invitation. And let me share my screen here. Can you see it?
Yes, we can see the screen.
Good. Yeah, I said thank you very much for the invitation to this panel. I'm so happy to be here, and also with this great company. It's also good that you have already introduced tile vaulting, so that everybody knows now what it is, because yeah, certainly I'm going to speak about it. Well, I'm going to focus on linking shell structural design and building crafts, and I would like to start with this drawing by the Guastavinos. It is the drawing of a cross-section of the dome of St. John the Divine in New York. And I like this drawing because it shows the material and structural efficiency of that construction. It is a dome that is nearly 30 meters span. And well, these qualities of material and structural efficiency make this cell structure so inspiring to me. This is the dome in construction in New York, and well, the Guastavinos could brag about their achievement, because in comparison with other big span domes at that time, theirs was much thinner, and as you can see in this comparison of different domes like the Pantheon, the Hagia Sophia, and the Florence Cathedral, which, as you can see, they were, let's say, like winning in this competition of efficiency. Apart from this structural efficiency, the reason why they got the commission of building this dome was mainly because they were able to build it without a formwork. And why? As Wesam was explaining before, because you only need minimal formwork to build a tile vault. In this case, they were using these strings to follow the geometry, and this minimal formwork made of, or false work, let's say, made of wood. And in fact, what they needed is really to follow the geometry in order to put the material where it needed to be. So, in fact, to build these amazing structures, they mastered cell design and construction, and they knew exactly where the material needed to be to withstand the required forces. And they knew how to build also their structures, because they have this craft and this know-how. And one of the reasons, or one of the tools that they used to design and to assess their structures was graphic statics. And in this case, of course, they only could do it in 2D. So now that I was explaining that these drawings and these works inspire my work, and I guess also the work by many others, we want to follow this efficiency, this know-how of how to build structures in an economic way. But of course, we want to use some current computational tools to do it. And luckily, we have now these tools to design not only structures with analysis in 2D, but also in 3D. This is a figure of some cell structures designed with the plugin Rhinovault. This is a plugin of Rhinoceros, and was developed at the Block Research Group at the ETH Zurich, and it allows us to design compression-only structures, which is exactly what we want for optimized structures, optimized masonry structures. So using this computational tool, this design tool, which was Rhinovault, we built already 10 years ago with Map 13 Barcelona, which is the office that I co-founded with Marta Domenech and Mariana Palumbo. We designed this pavilion called Bricktopia, and in that moment it was innovative, because it was the first freeform tile vault open to the public at such scale. And in order to be able to build such an innovative shape, it needed also innovation in construction. So what we did is that we had to link the shell design, which was an optimized structure, with a construction system that allowed us to build it economically and easily, or as easy as possible. So we provided some scaffolding and then some cardboards that shaped the shell. And then on top of that, we put some steel rods that were tied with wire to make the shape of the pavilion, so that then the cardboard could be removed, and then these workers could build the pavilion with a tile vault. And in this case, there was, as I said, such an experiment, the first free-form tile vault at such a scale. We were so lucky to have 5 different companies of construction companies that were experts in restoration and restoration of all structures, and experts in Catalan vaulting. So we had the best ones building it. So our first experience was, well, in that case, we were sure that it was going to be okay. But as I'm going to show later, then we will also try with well, either with students or with masons that were not familiar with the technique. So for decentering, we just had to remove these steel rods and just leave the unreinforced structure as it was. And then the steel rods could be recycled. And then this was the result. And after that, we in the next project that I'm going to show, we always try to go a step farther or to try something new. In this case, this other project is it's a tile vault in Colombia. What we wanted with the Block Research Group in this project commissioned by the UN Habitat was to try to export the technique, which some other experiences had already been done in Africa. And of course, there's tile vault in many places in the world, but for nowadays construction and for such a complex structure, we wanted to try it in Colombia, in Medellin. So as well, this is Medellin, and we can see that there's a lot of brick. So there's some knowledge of masonry construction, but of course, not of such vaults as we were proposing. So we proposed a similar scaffolding or similar false work system, but with some changes, as you can see. And we tried to teach local workers and also some volunteers that were in this in the World Urban Forum that was happening at the same time, and some volunteers from the university in Medellin, and to build this this vault. We have to say that, of course, it's a bit more difficult than working with experienced workers, but well, at the end, the result was nice, and well, I think it's worth it to try to export the technique that can be efficient to other places, and just teaching local community to build with the local workforce and local materials. Some pictures of the vault finished, and then I'm going quickly through the projects because I don't have much time to go. I prefer to do like an overview of many of the projects, and then maybe we can speak more about them. This is another project that we did, in this case, entirely with students. It was together with the Block Research Group and Mark 13 at AYAC. We proposed this vault. In this case, it was the slope was difficult. Doing it with students was also not straightforward, and also we were proposing to use some materials that they had in the site to build the vault. in this case, this base that they use as a horizontal platform to start building the falsework was then was produced with materials that they had there on site. So some little difficulties that we add to keep our research and our experimentation on the topic. So this is the result of the vault. Also optimized designing it with RhinoVault, so a compression-only structure. And then we thought that maybe we could also go beyond compression-only structures, and we could see how tile vaults could be combined with reinforcement or with concrete. And that's, in fact, the topic of my PhD at the Block Research Group. And I want to show again a figure or an image by the Guastavinos. These are patents by the Guastavinos, in which they already proposed some mixed of tile vaults with concrete or with reinforcement. And going deep into it, we can see that it can be a good option for many reasons. And one of them could be, for example, using this tile vault that you see in the image. This could be a typical tile vault, but then it could serve as formwork for reinforced concrete. And maybe we can start thinking about big span structures that make sense maybe to do with reinforced concrete, but then the formwork would be very expensive. But then we can use tile vault as loss formwork, or let's say integrated formwork, and then have a hybrid structure. This is what we proposed in map 13 for this pavilion that was a project, an idea commissioned by the City Council of Barcelona. And it's in the mountains of Barcelona, where a water reservoir was built in the 70s. And then there was a mountain there where you see this water reservoir, and they just cut the mountain and put the reservoir. So what we proposed for this neighborhood that in fact lacks sports facilities, we proposed this sport pavilion, which would recover the shape of the mountain and recover this space for the citizens. And our proposal was to build a tile vault and make it serve as a lost formwork or integrated formwork for reinforced concrete. So this is one of the proposals that we have been done, and another one is to make to combine tile vault with reinforcement. In this case, we had this little commission for Construmat, which is a construction fair. And in this case, AIAC had a place to show some innovation, and they invited us to show this little piece of our ideas for future constructions. And we showed this tile vault with reinforcement in between the layers, so that we could start envisioning some cantilevering shapes. And this is not chronological because I'm showing some different projects or little experiments from different times. So this experimental urban furniture that we did last year was once again our thought of combining masonry and reinforcement to make more, let's say, more exciting structures, and in this case structures that do not work only in compression. Some pictures of it. In this case, we had also the great luck to work with Jordi Domènech, one of the main tile vault builders in Spain. And after that experience with the master builder Jordi Domènech, then we proposed one workshop at the School of Architecture of Valles. It was also last year, and we built this little structure. It was again some kind of could be said like as a urban furniture, something like this, or a big bench, and on which we could all fit and do this typical load test. So we try always to combine the professional practice, research, also teaching with students. And in this combination, there's also something that I have not shown yet, which is this research also needs to have some more that sometimes is not shown this. It's not shown in this kind of talks, but there is behind that there is to know more about this structural design. We need to do a lot of these experiments with samples to know the material properties, the mechanical properties of the materials, and also I think it's very valuable to learn how to build this stuff by yourself. And I was very lucky to have again Jordi Domènech and some people from a company called Urcotex, including Antonio Aro and Pep Brazo, who helped me with all these experimental tests or building these vaults at the lab at the UPC. And it's a great experience also to be able to build them with your hands, to know how to prevent this kind of crafts not to be lost. No? So I want to say that there is sorry because of the noise. And all this research, these experiments with students and so on, they come together and in parallel with these other experimental tasks in the lab, which allows us to know more about the structural behavior of these specimens. So I've done some masonry variables, masonry sail domes, also combined with reinforcement and concrete. And then there's also these models, FE models, or different kind of structural models that we also need to be able to propose new structures. And to propose new things, we can also propose these structures with the same principles, but with different materials. And the principles would be to be material and structural efficient, and then know how this had to be built and who is going to be built to really propose appropriate structures. In this case, it's another workshop with students that we did already a while ago. And we wanted to show this shell design of this appropriate form of the structures with this so traditional hanging models, chain hanging models, to build stairs in this workshop that we did in Covarrubias in Spain. But we proposed a different material that was so light that the first layer of the vault was built super fast, and also could serve, if it was built inwards, could serve already as isolation. So this is the result of this experiment, of this workshop. As always, we did this load test and it worked. Of course, many things to do to keep improving in this research. And another completely different material also with students is cardboard, but the same principles to use appropriate structural shape. In this case, again, with design with Rhinovolt, but then taking advantage of digital fabrication, another way completely different to build structures, but being aware of this link of structural design, structural shell design, and the building way of and how things are built. And last but not least, Another material yet. Sorry that I'm going a bit out of the topic of brick, but I think it's also relevant to just to follow these principles. In this case, this is a project done in Norrköping in Sweden, the collaboration between MAP 13, Edita Agostinovic, and Summon Engineering, led by Didrik Perendal. This was, this is a timber active bending grid shell that I also bring to this talk because it also combines the qualities of being form found, so having a shape that responds to a structural efficiency and optimization, and also has a way of being built that responds to no formwork, that responds to trying to reduce material waste and to be more sustainable. And something else that is also similar to tile boards is that there is in this project also some inspiration in the past. And in this case, there is a clear inspiration in Fray Otto and the way he used form finding in this hanging chain model that we have at the left. We, of course, did not do it with chains, but we did it with computational tools. And the technique to build it, which does not need a formwork, because you can lay all the lats, the wooden lats, flat, and then lift them to make the shape of the pavilion. So this is the result of the pavilion and the conclusion of my talk. Thank you very much.
Thank you very much, David, for this very, very interesting presentation. We will hear all the talks, and then eventually we will have questions towards the end of the panel. So, but thank you very much, David, and Maria, maybe you can start your presentation now. Thank you.
Thanks.
All right. Hello, everyone. I assume you can see my screen, and if not, just let me know. So my presentation is going to be focused on pedagogy and research. I was asked to speak along these themes. So the presentation is going to be more focused on a specific course that we teach at Princeton and how that course evolved into some research experiences that were unexpected. So first, I'd like to acknowledge my colleague, Branko Glisic. He was the co-instructor of this course with me, and then later on developed the research that I'm going to talk about. And also Isabella Douglas, who was an undergraduate student at the time that she took this course and developed research as a result of it. So first, I'm going to talk about the integration of research and teaching, again, through the example of this specific course. So integrative and innovative, and you're going to see a few alliterations here. And then I'm going to talk about Candela and Cuba. So this course takes place in Cuba, or the context is Cuba. And I'm going to talk about Max and mysteries, meaning Max Borges, the architect, and the mystery behind his collaboration with Felix Candela. And then finally, I'll end with the tile vaulting of the School of Ballet that's there as part of the School of Arts, and answer the question, is it Catalan vaulting, honestly, or is it a counterfeit Catalan vaulting, which is also enveloped in a bit of mystery that, anyway, I won't give a spoiler, but I'll talk about the School of Ballet at the very end. So starting with the course itself, the integration and innovation between research and teaching. So typically, my research, the research that I do ends up in the classroom, and I teach that research. But this was a unique experience where we sought out to teach a course related to Cuba, and that course actually developed into a research project. So it was the reverse direction of what might be the common path in integrating research and teaching. So I want to start by saying how important it is for engineering to embrace not just the pedagogy of engineering, but go beyond into the humanities. So I am an engineer. I was trained as an engineer. I teach engineering classes. And I love this quote by famous philosopher Ortega y Gasset, who says that I wish it would dawn upon engineers that in order to be an engineer, it's not enough to be an engineer. Meaning you have to embrace the humanities, because we're not engineering in a vacuum. We engineer for society, we engineer for culture, for context. So we have to be sensitive and learn about that context. And then the innovation is a new course that we started teaching this in 2010. We teach it every 2 or 3 years, more or less, because it's a lot of work, as you're going to see. And we call it a social and multidimensional exploration of structures. So here in this year of 2016, the course took us to Cuba. And the theme of the course changes every year, but the pedagogical objectives remain the same. And before I get into that, on the far right is my colleague Branko Glišić, whom I mentioned in the very beginning of the lecture, was a co-instructor with me. I'm all the way on the left. The students are in the middle. We traveled for 1 week to Havana. And then the very center is Jose Mosqueda, and I will introduce him to you in a moment. All right, so this course was designed for juniors and seniors, meaning 3rd and 4th year undergraduate students, although we do have every once in a while a few graduate students who enter the course as well. And it develops skills in drawing, model making, writing, oral communication. And again, because this is an engineering class, engineering focused, it does also have advanced engineering analysis. And this last part is what one would expect to see in an engineering course. What's not expected are the skills in drawing and model making, for example, which we believe have an important place in the education of the engineer. And as I mentioned before, because we don't want to think about engineering in a vacuum, we talk about the social, political, historical context. We talk about aesthetics in the course. And as I said, the theme changes every year. 1 year, for example, in 2014, it was the art of Spanish bridges. So we were in Spain, touring and visiting bridges in Spain. In 2016, 2 years later, we picked the thin shell structures of Cuba. So we called that class, the sub-theme was creativity in Cuban thin shell structures. And as part of the outcome of the course, the students had to make a website as well as an exhibition. And again, this was to encourage that teaching of communication to the general public. So how do you communicate your ideas and excite an audience about the work that you're doing? So here is the exhibition featuring the models the students made in groups related to the thin shell structures that we studied in Cuba. And in the left, you'll see the model of the Ballet, the School of Arts that I'm going to talk about in a moment. All right, so as I mentioned, we want to put context into what we're learning. So we talked about a little bit of the history of Cuba. There was the revolution, Castro ousts Batista, and after that, not much is constructed. There's a serious embargo on US and imports. So the idea that we teach in this course and also in other courses that's taught at Princeton is that constraints enable creativity. Sometimes these constraints come about due to war or whatever the context is, but it opens up the idea for creative thinking about, in this case, construction. So we visited several shell structures. It turns out there was quite a lot. We did a a tour before we taught the class to make sure we had enough content there to teach a class on Cuban thin shells. So here's an example of another structure. There's Parque Deportivo that has this horizontal cantilever and another closed-in structure. So there was quite a bit of thin shell structures there. And as I said, we also dive into some high-level engineering analysis. So we also taught shell theory to the students, as well as the more humanistic kinds of studies. And within that study of structures in Cuba, thin shell structures, we uncovered quite a few of structures that were done in collaboration with Felix Candela. So Felix Candela was famous for his hyperbolic paraboloid structures that were done in Mexico City in the 1950s, 1960s. He did a few designs outside of Mexico, and a few were in Cuba, and mostly in collaboration with Max Borges and his brother Enrique. And the Max and Mysteries is the, I'll get to in a few slides, because there were a few structures that he was credited for being a part of, but I'm not so sure of that. So we're talking about Max Borges, and we're talking about pre-revolution, before the embargo, before Castro comes in. All right, so here is Candela. As I mentioned, he's famous for his hyperbolic paraboloid or hypar structures. And the geometric feature of the hypar is that you can have double curvature generated with straight lines, as you see in the sketches on the left. And so here's a structure where you see the straight line generators that create this very large hypar shape. And in the construction images, you see those straight lines that are used to form the scaffolding and later on the formwork. Here's another structure of his, is the church in Mexico City. And from this church and the form of it, you can start to see, going back to Cuba now, in Havana, the Núñez Galvez tomb. This was a collaboration between Candela and Max Borges, 1957. There was no information in the archives at Princeton. There's another set of Candela archives at Columbia. There was no drawings or dimensions or information on this tomb. So when we visited with the students, they were able to take measurements and lay out that geometry of this tomb. And what we can see now are not just the geometry and the layout, but then they were able to, with this information, create some structural analyses and understand the structural performance of this tomb. So there was other projects done by Candela, and in this case, Enrique Borges, the brother of Max Borges. And so here we see a house. I believe today it's the consulate for Venezuela, so it's no longer a home. There is the Andilla flower shop. It's one big hypar umbrella. What you don't see is a single column in the center of this, what used to be the flower shop, but no longer a flower shop. And across the street from the flower shop, a smaller hyperbolic paraboloid umbrella used as a bus stop. One of the most famous shell structures of Havana, Cuba, is the Tropicana nightclub. And for this, Max Borges, who was the architect, received an award. It's still active today. Fortunately, we were able to see a performance inside of this space. So it is quite a spectacular space. And here's a rendering of the 5-barrel shells that form that almost telescopic looking structure. And the students, again, there was no information in the literature about the dimensions of the structure. So using a digital laser, they were able to take some coordinates and some dimensions and make some structural analyses of these shells, which essentially always have just confirmed the structural integrity. If we go into the literature, there is an indication that that Felix Candela collaborated with Max Borges on this structure. I've looked and dug into the archives at Princeton and at Columbia. I can't find any evidence of this being a fact. In my opinion, actually, Candela did not collaborate with Max Borges on this project. Not only are there no drawings, there's a lot of communication in the archive at Columbia between Borges and Candela, and I read through all of that. There has been no conversation about this project. Another important shell structure in Cuba is Club Náutico by Max Borges again. And the same conclusion here, where there is references to Max and Candela collaborating, there really is no evidence. If we dig into the archives, again, no construction drawings, no mention in the many correspondences between the two men. So that is the Max and Mysteries alliteration I was referring to. So from this kind of surprise of how many Candela structures there were in Cuba, I have published quite a bit on Felix Candela. And so taking this opportunity, working with the students and the trips and the research that we did as part of the course, we were able to publish a paper in the IASS about these shell structures of Candela and Borges. And I was also invited to write a piece for a book that was published about Candela and his works related to Candela in Cuba. So this is an illustration of how, again, as I said in the beginning, we sought out to just teach a class, and it ended up being actually bringing in a whole lot of discoveries in terms of research. Another area of discovery in terms of research related to this class that we taught in Cuba was related to the School of Ballet. So Catalan or counterfeit, and this is different from Candela. Candela was pre-revolution. Now we're talking about post-revolutionary structures. And I'm going to focus specifically here on the National School of Arts. There were 3 architects involved in this project. You see them listed at the bottom of your screen. And there were 5 schools. So I'm going to focus on the School of Ballet, where the architect was Vittorio Garatti. So before going to visit with the students, the School of Ballet, and actually before we did even the reconnaissance tour, before even taking the students, we contacted Vittorio Garatti, and he directed us to Jose Mosqueda, who was still living in Cuba and was essentially his right-hand man. He worked very closely with Victoria on this project, the School of Ballet. So we were able to contact him, and he went on site with us and showed us around this project, giving us also stories about his own personal experience in the design of these structures. So here is the inside, and in the background, the outside of one of the classroom domes. And you see the rib vaulting at the top, and you see the tiles on the outside. And on the edges, you see the layers of what was assumed to be this Catalan vaulting construction technique that you just learned about in David's presentation. But then at a closer look, where the tile layer came off over the years, what you see behind that tile is actually concrete. And there was this hole in there that not only do you see the concrete, you start to see reinforcing steel on the inside. And this led us to question what is this built out of? Because from the edges, you expect it to be layers of tile. And that was the intention. That was actually, in the end, probably an aesthetic touch. But it was actually a reinforced concrete structure. So in approaching Jose and saying to Jose, what's going on? Is this reinforced concrete? Jose would say, yes, of course it's reinforced concrete, as if, it was a matter of fact, and as if the world knew that that was indeed the case. And opening up his photo album of the construction photos, Jose showed us the construction procedure, which indeed validates that it is a reinforced concrete dome structure. So here you see the formwork and the steel, and it's getting ready to pour the concrete. So Isabella, one of the students in this course who developed research based on the School of Ballet, she did an inventory to indicate where do we have in this space stacked adobe brick, where do we have concrete, where do we have thin tile vaulting. So there is some honest thin tile vaulting in green, and these are essentially the covered spaces in between the classrooms and the dome. So the largest structure in that space is this ballet school right here, the dome structure that you see here. And again, it's intended to look like tile vaulting, but it isn't. It's a reinforced concrete structure, as well as indicated by the drawings, the construction drawings that Jose showed us. And so Isabella took this structure and she made structural models of it to, again, just validate the performance, the structural performance of this structure. So here are the meridional stresses and the hoop stresses, and it all results in a conclusion that it is a structurally sound structure. She also did some graphic static structural analysis and some very basic shell theory analyses to validate the performance and validate these more complex models as well. And from this, just like in the Candela project in Cuba, we were able to publish some journals about this structure. So the first paper was Isabella and the research that we did as part of this course. And the second paper was a more detailed analysis that was lending more towards the performance of these structures with a purpose of possible rehabilitating these structures and bringing them back into use. So the second project was done in collaboration with our colleagues in Italy. So we see Sofia Celli, Federica Ottoni, Davide Del Curto, and they are in Italy, and they're working in collaboration with a team at Princeton. So in summary, the research and teaching, the integration was really something that I hadn't yet experienced. I sought out with my colleague Branko Glisic to teach a course about Cuba and Cuban shell structures. I didn't expect for it to really explode almost into a lot of other research opportunities and discoveries that were good. There were new opportunities for everyone. Candela in Cuba, Max and Mysteries. I think here, I still believe that Max Borges and Felix Candela did not collaborate on those two structures, the Tropicana and the Club Nautica, which is different from what is published in the literature. And finally, in the School of Ballet, it is mostly not a Catalan structure. The vaults are reinforced concrete structure, and the research in general, I believe, made important contributions to the knowledge of this heritage site. And that is the end of my presentation. Thank you for the opportunity to share.
Thank you so much, Maria, for this fascinating presentation where we could see like integration of education, research, practice all together. I can't wait for the questions and the discussion among us. I think there are many beautiful themes that are emerging from these presentations. Thank you very much, Maria. And now we will move to Robin for his presentation. Floor is yours, Robin.
Thank you. Should be this. There should be single slide. Nice, that's great. Hi everyone. So yeah, I'm glad to contribute to that panel. I will be showing a project that we've done recently in collaboration with Wesam, so the Inixar prototype, which is a thin tile vault where we're trying to minimize the false work. So that includes guide work and centering. And I will show you how with the team we've been leveraging design technologies regarding digital technologies regarding both design and construction for construction craft. So as part of the SCAF-free project based in Princeton, but we have an extended team, and that project was on that collaboration side with Wesam when he was a visiting scholar in Princeton, and we've been developing that that aim to showcase how we can actually so minimize the force work for masonry construction. So it was a fairly large group, a fairly rich collaborative process between researchers and visiting researchers in Princeton in the form finding lab. And we had the chance to be able to work with Bovederos, of a master vault builder, Salvador Gomes Avino from Movida Tabicada, and who collaborator of Wesam on the Circa initiative. And Wesam was hosting us at IE University. You can see the beautiful site with a university at the bottom, that's just outside the city, with amazing cathedral on the right and famous also aqueduct right outside the picture on the left. And we felt like we needed to make our small contribution in terms of masonry. You can see it at the bottom here. So on the, let's say the garden or the terrace of IE University, like so facing the valley and the other hills. And so that's what we did in a couple of weeks, a month ago in March. And I will walk you through the process, how we design and build this. I really like that picture because as you saw, it's a very rich site where we had to work. So it was just this terrace, so it was hard to reach with maybe a machine. So we had to actually lift a small vehicle to be able to bring the concrete to cast the slab on which the masonry vault relies. And I like that picture because that shows that it's actually proof of all the hidden work that happens on the construction site, all the sort of false work, everything that's not seen at the end, all that's part of a temporary work. And it is exactly the kind of things we want to minimize or reduce. So when it comes to false work, so that includes scaffolding, formwork, centering, guide work, everything that won't stay. This is actually extremely detrimental for shell structures and vault structures to be economical and affordable. The structure then might be extremely efficient, but while building it, then as you can see on that concrete shell, the knit in Paris, most of what you see here is actually going to be removed at the end. And so that's a lot of hours, a lot of time invested, and that's actually can deter you from leveraging these efficient structural systems. So that was a concrete shell, but in masonry, because of its different nature, actually, builders have been developing a set of method to reduce or even remove the need of false work or centering in the case of masonry. And some strategies are a couple of millennia old. So you can see the corbelling technique, just stacking bricks with small cantilevers, quintal vaulting, which is what we are particularly interested in today, thanks to where we use this fast-setting mortar and the lightness of the bricks. You have pitch vaulting, where you're inclining arches and leverage friction to build arch by arch. Then you have a couple more strategies that are also extremely interesting, which is adding external forces or pre-stress, maybe with cables with hanging weights to compress an arch while it's being built. Also very networks, you can see it in Gothic construction, but even before in Spain as well, in the Arabic world, where it provides this hierarchy in the vault. So you have this, you first build arches, and then you put, you build the rest of the vault on top of it. And you also have the Hermon pattern that's been used by Brunelleschi at the Santa Maria del Fiore Cathedral in Florence, where you have these bricks that actually somehow cantilever. They're being clamped by one course of bricks, and they're allowed to provide additional extremely stiff supports for the next one. So that these are techniques that have been inspiring us, and the team has had quite a lot of experience in terms of first construction, thanks to Salvador Gomes Avino. You can see on the left this beautiful project that is completed a couple of months ago. And what's interesting is that you can see on the middle from the top view, you can see the guide work. So mainly a guide work to follow the right shape of a vault, that to build it as designed. But also that acts as some light support or a couple of simple supports. It's not as complex as what we saw before for a concrete shell, but it still takes time to put it together. And it's the same for even smaller projects as Salvador and Wesam have been doing with Circa. So you can see on the right that before you build, even if you use quintal vaulting, even if when you have to start, and you've also seen it on the project of David, you have to start somewhere. So whether it's a wall to hold the first arch, or whether you want to have this kind of so this guidework or centering on the boundaries, you can see at bottom right. So you have this flexible metallic strips that are bent and propped to put together, and then you actually complete the dome from the outside in. So you do need this, even on a small project, you still need some level of false work. And so here we've been trying to leverage various experience that we had in the team that ranges from at the top, so find inspiration from Nubian vaulting and Persian architecture, so you apply to 3D printing, clay shells without supports, to use the collaborative robotic assembly to build the first arch that will then act as support for the rest of the vault, understanding the mechanics, the herringbone patterns of Brunelleschi with this flat arch or plate-down system, and that does allow you to build that additional support, so you have this internal support, but also investigating form-finding techniques where you actually have an idea of sequencing, so you actually achieving equilibrium at different stages of the process, or actually in the analysis of a structure. So with all this inspiration from historical methods to existing construction work done by the team and research directions, we've been developing a strategy to try to drastically, almost caricaturally, remove as much false work as possible in that project. So schematically, we have this vault with 3 arches, so this 6-sided dome. And so thanks to Fintal vaulting, we're able to remove all the centering that would be filling the vault. So that way we only have a couple of arches that we need to act as guidework. So we have a waffle frame kind of thing, as we've seen before, maybe arches on the boundary, but these are quite complex to make, especially if you can imagine with structure, a bit more freeform structure. You have double curvature, so they are to build, and then you still need some guidework. So what we're using is finding inspiration from rib architecture. So having this hierarchy. So we're using a spine, which is what you can see in green. So that instead of having long curved arches on boundary, you have this more efficient and rationalized planar set of arches in the middle that act as a spine that can be prefabricated. And then you still need guidework to inform the builder. So what does the rest of the shape look like? And so to remove that need for guidework, then we are leveraging augmented reality for construction to move from physical to a digital guidework. So we first developed the construction strategy, and then that informed the design process. So we have a 4D funicular design process, in the sense that we're integrating the construction of the assembly steps of the time components in the design. And for that, we had to have a dialogue between finding the right shape of the design, but also what should be the pattern and what should be the sequencing. So what is the hierarchy in terms of construction? And so that's why we have this spine strategy that will give you this 3-legged arch in the middle, and from that you actually see that naturally forms a crease, because we're building from the inside out, and you want to have this natural slope, so that when you're putting a set of arches, they should rest upon the previous one and not be below. So the shape was naturally dictated by this constraint, the embedding of these objectives that stem from construction. This is a sequential form-finding process led by Rafael Pastrana. You can see the form-finding of a spine initially that will be made of, that will be prefabricated. Then we're adding step by step so as a force network that represents the addition of a couple of courses of masonry. We actually add those, and what we try to do is to actually have step I informing step I plus 1, so that you have a minimum deviation when it comes to the sequential form-finding process, because we want this to describe the same geometry, and ideally we want this to represent the equilibrium of the first layer of tiles, which is a critical one, which is what we achieve here. So the first layer would be 33 millimeters peak, and here were the deviations at the different stages around 20-25 millimeter. So it was a successful process that was thanks to this constraint from finding optimization process, then in sequential steps. Then came to this force network, then came materialization, so the vault of the coursing. So you can see schematically the brick coursing in gray, but also in brown you have this herringbone brick, so inspired from the Brunelleschi construction. So that's work done by Vittorio Paris, and you can see that because they provide small steps. The goal of these bricks is to actually so while you're building thin die vaulting, you have to rely on the fast setting mortar, and sometimes you have to pause, you have to take a break, you have to move to another section, so you have to let the mortar cure. Here, that's a stability system that does not rely on the material, but relies on the art that you're currently building, but that relies on the clamping of the brick that's being clamped by the previous arch. And so that's why we integrated that tessellation in it. So as a materialization of the vault, and below you can see the spine that's actually prefabricated and rationalized, so that that can be simple to install on site. So it's actually made of layers of plywood, so CNC plywood, so accurately produced off-site, connected together. You have these 3 arches that are all planar, so they can be made from regular boards, and then they're connected by steel nuts, so between them and at the anchors. And then the 3 arches of that spine are made separately, pre-assembled off-site, and then assembled on-site, which I will show a bit later. So that was a process that was very simple elements, and what here we relied on was the accuracy of these things, because then we were using the spine also as an initial reference in the physical world for our digital guide work. So we're using augmented reality, so with headsets for the builder, because the aim is that so masonry material or construction has to face so many defects and things that are hard to foresee, and so because of the nature of the bricks, the mortar. So here we're relying on, we're not trying to automate the construction process, trying to bring tools to the builder, so Salvador, to be able to make informed decision and to solve problems with intelligence and experience on site, while we're only providing him the design intent. So here you can see the different shape, so the different curves that provide the guidewire. So we have this alternation of lines in yellow and green, and these are the main line courses, course lines. And then you have transversely some L's so that you could actually visualize the entire shape, the entire vault, understand the double curvature of it. But we're not providing him exactly the tessellation. It was up to him to actually adjust, adapt, and decide. We're actually only providing him information about the irregular parts of the vault, which are these gray areas, gray surfaces that actually show the herringbone bricks, because they actually are the singular parts of a design. Then what you can see in black, they're actually the lines, the key lines of spine that was helping us as for calibration between the physical and digital world, so that we can leverage that guide work. So that's what it looks like on site. So that's a snapshot taken from one of the HoloLens 2 headsets, so where you can superimpose the 2 worlds. You can see here we are almost halfway through. You can see the superimposition of the 2, and that's what the builder was seeing. So that's a Salvador building a couple of bricks, and that's where you can see the development, or like the application of the craft from the Bovedero himself. So you can see here on the very regular part of the vault, so just about putting bricks, so one by one, but extremely efficiently. You can see, thanks to experience in craft, it's about putting this fast-setting mortar, gypsum mortar, for most bricks on 2 sides of the tile, and then adding it to a vault. The vault that had the geometry that was again informed by the construction process. So we are checking we are a bit careful about what slope the vault should have, taking into account the sequencing, so the construction of it. So that's why it was actually fairly easy to put these regular bricks, and you wouldn't have to hold it for too long, which will be the case if you come to more horizontal or shallow vaults. Now let's see, this is the time lapse of the construction. So you saw just in a glimpse, the spine has been assembled in maybe half an hour, pre-assembled and assembled on site. So that was the only physical guide work that we needed. So this actually spine or rib that's going to be integrated into the vault, and then started the construction process. So so first the production of these squinches, so small triangles that are part of the top of the vault. So they make this smooth transition from one straight arch to the other. So here there's quite a bit of cutting to be done. You can see the workstation on the right. That's where there's a lot of clay dust coloring the grass in orange. And then once you make it to the regular part of the vault, then it goes much faster. We're facing a couple of changes at the start because we're leveraging that augmented construction technology for the first time, or like one of the first times we picked up on that in the last 6 months, let's say. And so we had to calibrate things from our initial indoor experiences in the controlled environment to like the reality of a construction site. But once we made a couple of rookie mistakes, then we managed to be efficient and productive. So we actually built the vault itself in 4-5 days, including the second layer. You can see the second layer of thicker bricks that's being assembled at the same time, that we could reach from the top, and so we could have different workstations. So Salvador, using the augmented reality goggles, completing the first layer, and us working on the second layer, and also assisting him. This is the final day, at least for the actual vaulting itself, where you get the completion of the vault. Obviously, the second layer goes much faster. There's no need for digital guide work because the first layer is there. That was a faster step. And then that's when the structure is done. You can see that was already used, in use. There was an event a couple of weeks ago on the IE campus. But this is not, we didn't do this just for the sake of putting a pavilion to it. So here we're crunching the numbers to actually see what was it, let's say, in general, the cost of a building or building that vault. So it was not just about how much does it weigh. We want to also check the embodied carbon, but if you're using guide work or also it can be reused, that doesn't have a major impact. Really what I want to check is, can we make, thanks to this leverage of digital construction technologies, can we actually make these things more affordable? Or let's say how much, maybe not money, but because it depends on the context, but as a proxy, how many hours of construction time did we actually save by leveraging that prefabricated spine, thin tile vaulting, and the augmented reality technology. This was all informed, like integrated into the design process. So you do need to have this kind of new skills, new craft, let's say digital craft, to go in hand with a physical craft. But you can have a look at these figures, but it's work in progress. So I don't guarantee anything regarding the accuracy. I would just say stay tuned for more publication where we're going to provide these numbers and to assess it. But we do have more coming. So because one is not enough, we actually contribute to the European Cultural Center exhibition that's in Paris with the Venice Biennale, which is going to start in a couple of weeks. So we also felt like we need to add our contribution to the Palazzo Mora. So with a similar team, but extended actually with a couple of companies, architecture, engineering, and construction companies. And I thank you for your attention.
Thank you, Roman, for the presentation. This is really great. Thank you so much. It's really on topic when it comes to the interface between technology and craft. So what we'll do now, I'll use about 10 to 15 minutes to present an experience that I was part of for the last 5 years And after that, we will start taking some questions. Those who are watching us, you can start direct questions also. I want to talk about three main directions that I thought through the work that I've been doing with time vaulting. It kind of it makes an interaction between what is the craft and the making and the design or the design decisions. And those are 3 T's actually. First is tools, the second is tactics, and the last one is technology. And by tools, I mean really the actual tools that you find on site and how you can interfere with that. And I think Oban's example with the HoloLens is pretty much on the spot in this realm. Like if you provide a new tool that of course entice a technology or a new technology, how would that affect or impact the craft of making of tile vaults or tile shells? The other one is tactics, which is not really about the object that you use to build your structure, but more about how you strategize your construction. And last is technology, is to use software programs and developments of fabrication or analysis technology to influence or to make more informed decisions when it comes to construction. And for that, I will present 3 projects. The first, actually, it was when I was a student myself. This was back supervised by Michael Ramage at the University of Cambridge. It was my master thesis, and my prompt for there was to actually invent a tool that can describe a parabolic curve so that the builder can use it without the need to actually fabricate formwork for each curved section. So it sweeps, rotates, it opens and closes, but at the same time, whatever it does this, it always describes a parabolic curve. And for that, I used different thicknesses along the section to build to invent or to come up with this tool. And eventually we used laminas of bamboo to build the structure. And you can see we tested it on 3 small scale vaults so that we can see how much we can take this bending technique to the formwork as a formwork in practice. And here is the construction process of the vault. So when we used multiple ones, we used it as formwork because we needed support. When we used only one, it's not strong enough to support, but it's strong enough to guide the work during the construction. On another example, which is tactics, this was another project that was part also of my PhD. Here, I was not really investigating or looking into the tools that we're using, but rather the strategy of construction. And for this one, we decided to build a vault, slice it, and then transport it and glue it back again. So it's a form of a really non-conventional prefabrication of construction, which has resulted in many problems, but also opportunities. So for this one, the design of the sequence of the construction was pretty much influenced by the manual work. So how much a piece can weight so that 2 builders can hold it on a scaffold or without a scaffold. All this has informed the way and the design of these structures, which then were fabricated in a workshop, on an offsite workshop. And then as you can see here, we build it, we cut it into slices, and then we transport it to sites. And the reason why we actually did that is that because on site, we had a really narrow construction window. We didn't have as much time to build a vault with such complexity. So we had to build it in pieces and transport it to rebuild it again. This was part of Tibisama exhibition in Valencia in 2018. And it was, again, this project and the previous project was also built with the generous help of Salvador Gomez, another vault maker who's in Spain and who's always working with us on the development of these projects, on the experiments of these projects as well. And that's more or less the final product of this. The last one is also, actually this time it was the opposite, with Salvador, who called me and he said, like, I have a project, I need your help, which I find really fascinating as well, that this happened sometimes, and it happened not only once or twice. For this one, we had quite a different problem. We had a cave that was previously inhabited, but it needed rehabilitation. It's a private property. And instead of doing it with, instead of tearing it down, for the rehabilitation, the choice was to do it with tile vaults. The problem with this is that we really didn't know what to do with the geometry of the cave itself, because we didn't want to excavate that much, but we also didn't want to put too much material also as an infill that much. So what we used for this was we used photogrammetry to 3D scan the space and to actually note on the model of the space the different geological kind of property of this cave, and then to form fit really the vaulted structure so that it can support the cave, but at the same time it can contribute to the support of the cave, so and at the same time it does not require that much excavation. And that was developed through different and a series, of course, of solutions to eventually come up with one. So here, the input was from Salvador, the craft person, from the client, but also from the geology of the structure that we're building for. And this is a photo of the final solution, and this is when almost finished and during the construction. So within all this, we were thinking about a platform in which we actually combine the experience of engineers and builders. And Circa came up with Circa as this platform, which was co-founded by me and Salvador. And the main kind of premise of Circa is that now we hear a lot about craft programs being an apprenticeship program in a traditional way, and that takes so much time in today's world, whereas workshops today are very concentrated. It's a 2-week things, and then you know about the technique, but you never practice it. But instead of approaching that through this linear kind of two timelines that are not identical, we thought about making it more of an activity and a community. So whoever is part of any of the workshops will always be supported by advices, consultancy, and maybe extra sessions if in a project, for example, for them to continue their learning if they wish. With this platform, we managed to build several vaults and pavilions. All of them were built in collaboration with either apprentice programs, vocational programs, vocational training programs, or with university students. This is in Santa Pola Center of Art, which is in Valencia. This was in collaboration with the Princess Foundation in their summer school of craft in Scotland, and this is one that we did ourselves in Valencia. It's something that I really like to tap on all these experiences, is that a workshop is also an opportunity for a research, and a research is also an opportunity for a workshop. So again, it's somehow echoed what you, Maria, said about something being an educational or a pedagogy kind of activity. It kind of spring into something that is more that can influence the research. And with that, I would like to finish my little explanation about the experience of Circa and my experience also in working on with tile vaulting, masons and builders. And I think that concludes our presentation. So it would be also great now if we can turn on our cameras and maybe start a little bit of a discussion. I'll see. While we're still receiving questions from those who are watching us, I would like to. I had some other questions that came to mind when I was hearing your presentation, and I will start with the same order, but then we can switch. So David, how you talked a lot about the use of tile vaulting as a reinforcement for concrete shells, or as a composite where two things really blend into each other. I wonder how and you also showed us prototypes of that being developed with builders. How was that kind of received by those companies who worked on who they have their own experience on the craft, and they have their own experience on rehabilitation of historical buildings on the subject?
Yeah, you know, because you are in the world of tile vaulting, that there are some let's say radical followers of tile vaulting that would say that it's just a sin to mix tile vault with concrete, and I kind of agree for historical buildings. So if we know how to build with tile vaults, and we know how it works, then if we need to do any kind of restoration of a historical building, then we should use the same system and the same materials. And but as soon as I explained that would be okay only for new constructions, and the advantages that this could bring, depending on the context, of course, depending on the span of the shape of the place where you're doing it, depending on many things, but it could be an opportunity, then it's quickly understood. And in fact, what is more difficult is to build the tile vault. But any mason that is able to build a tile vault, then it's also able to, or has worked for sure also with concrete or with reinforced concrete. So that is not the main problem. So if having the luck, as I said before, to work with experts in tile vault, then it also means that they are experts in general construction. So it was not difficult to do these prototypes, and it was also great to work with people that is in fact so open to new things, and also so happy that to really to try to extend this traditional technique and to try to keep it alive, and that even do it just for the sake of helping us going a bit farther on this research. So that's great.
Thank you, David. That really links a lot to my question for you, Maria, which has to do with the dome in the School of Ballet. So was it intended to be a tile vault dome, and then they figured out that this is not working, we should do it as a concrete shell with an appearance of a tile vault? And the other related question is, you mentioned Mosqueda. Was he an architect and an engineer? What's his background in the project?
Yeah, great question. So I'll start with the second question. Jose Mosqueda, he was a student of architecture of Garati, and he said that the students of architecture would have classes in the morning, and then in the afternoon they would build the structure. So that was, part of their work. Part of the work as a student was to build the structure. And Jose was one of the lead in that construction. So then and I think he actually, I'm almost sure in that photo album, he shows a picture of the students in the classroom learning. Yeah, so he has some really wonderful photographs, and I'm going off on a tangent a little bit, but this photo album is really a treasure. And we asked him, could we take this home and we'll take photographs and we'll bring this back to you in the morning? But he would not part with this book. He would not let it go for a minute. So we invited him to the place we were staying, and we offered him coffee, and we said, can we photograph this while you have coffee? And he said, okay. As long as he was next to the photo album, he was fine, but he wouldn't leave it. So we're grateful to have, I showed you a few images, and there's some really, like I said, photographs of him and others as very young men. students of architecture in the classroom and working on the project. And then the second question is, was it intended to be reinforced concrete all along or not? There is no indication that it wasn't intended to be reinforced concrete all along. Jose is probably the biggest source of information there. There's certainly nothing written that I could find, but he never mentioned anything other than this was always intended. So I mentioned that when we realized this is not Catalan vaulting, and we were kind of in surprise and went to him saying, Jose, and he said, well, of course it's concrete. We have 1 inch bars at 12-inch spacings in that leg that you're looking at. He had it all memorized, even like without even looking at the drawings or anything. He remembered decades later exactly what size bar and what spacing they had in those legs. So his response and then the conversations, it basically indicated it was supposed to be concrete all along. So yeah, but he, like I said, he was the biggest source of information for that question.
Oh no, that makes sense. If he's convinced with it that so much, but maybe it is as he's saying.
Yeah.
Roban, from your presentation, maybe you can also explain a little bit about the digital formwork. What are how did you develop those? How did we develop those? And to what constraints we have during the development of and why is this mesh exactly and not other pattern, for example?
Yeah, so for the digital Garlock, so the actual model, so which is what information do we bring from the digital design to the actual builders. I think it was a trade-off between so first the idea is that this model would be like an aid for the builders, to not be like a brick by brick tessellation, because then we could have provided something like this, and then suddenly there's something we haven't foreseen or that might not be foreseeable by anyone, then we just have to change everything. So that would not be possible. So too much details is not worth it. It would actually be a lot of work for no reason, because the builders knows how to do it. So it was really like the guidelines of the surface, and also a bit more strictly, but also in terms of patterning. At some point, also giving not enough information in that model, so we only have like one set of lines, and that was not enough to visualize the thing properly, to understand the shape. What was interesting is that because when you're building something, except for if you go to a blueprint, you don't see the future structure. Yes, Salvador would see the future structure, that is the shape, so many hours per day. So again, he would have the 3D model in his head. So that's why these lines were important. But again, just to get a sense of a surface, not necessarily a tessellation. And again, another last point was what was critical was to emphasize these special areas where the tessellation would become different. That way, I felt that he was working working let's say surface based. At some point, for the regular parts, we're just putting arches, very fast. And then sometime in the model, we need to have something bright that says, okay, now you have to think about not the surface, but the tessellation. You have to change your mindset, focus on this, then you can go back to a more productive mode.
Great. I think that also leads to a question about learning, learning in the sense of learning in engineering in general, and learning of building techniques also as part of architectural and engineering educational experience. And this time I'll start with you, Maria, because you've presented something that it was a project that is a course. And I'm really fascinated by exactly how much it has been unraveled from just taking a trip to Cuba and working with students on different things, and then finding out that there are so many opportunities. But what really also fascinates me in what you presented is that the fact that sometimes in the absence of archives, the buildings, they became the archives themselves to kind of harness more knowledge about this. And in historical structures, this is the case, like we acknowledge historical structures by doing this 3D scanning and all that. But I think in your case, it was more about, it's a heritage, it's a modernist heritage kind of architecture, but it's an abandoned one. And I think it's really amazing. So how frequent do you think, like, even architecture students can also engage with the measuring or the reverse engineering kind of activities during the course, and does it really differ from being, for example, in the US, where archives of buildings are available most likely, whereas in different contexts such as like Global South, you can have many of these gyms that you called, but at the same time we don't have drawings for that. How can we use the knowledge in these institutions to kind of enrich our understanding of an architecture that it's not historized or written for?
Yeah, I'm not sure I fully understand your question. Maybe it's how can we study these historical structures in the context of the university? Yeah, I mean, I presented one model. There's always the graduate student research path as well. So you have one student. But this model that I presented was, we cast a broad net. We weren't intending to catch research with this broad net. We had to, because we had many students. They had to work in groups of 3, each group with different projects. I think we had 5, 6 groups. So we had to find 5 or 6 really interesting structures for them to study. And hence, before actually launching into this course, we had to visit Cuba. I had never been to Cuba. I had never heard of the National School of Arts before. And this was and this is actually maybe part of the story of why the humanities. And the reason Cuba was that I was having a conversation with a Professor Ruben Gallo, who's a scholar he's in the program of Latin American Studies, right? And he was very interested. We were just having a casual conversation. And he said, I'm really interested in doing a study from the engineering aspect of Cuba. He had started this research on Cuba. And I said, I teach this course. Maybe if there's interesting structures, we can work together. So it was a very kind of organic, kind of a side conversation we had. So he organized a trip with me and a few other faculty members to explore studies in Cuba. And then through that experience, I realized there's a lot of shell structures here. And I had already done a whole lot of study of Candela. Along the way, picked up some clues that there are some Candela structures there, but it wasn't clear to me, what. And so we cast a wide net because of the class, and that enabled this kind of research. So maybe casting a wide net, picking a region, and in a similar fashion that was done here, and thinking about, once you cast that net, what is in that space that is really worth the kind of deeper dive, like we did with the National School of Arts, with Candela, dispelling some myths. There was quite a few myths there. There was a myth that one of the reinforced concrete structures had no steel in it at all. It was just concrete. I don't think that's true either. But, so these are the kinds of things that, because like you said, there's no documentation many times, there's sometimes you have to dig much deeper than the archives of the government. You have to find a Jose Mosqueda who's still alive. In this case, fortunately, he was still alive, because some of the structures that are out there, there's no one still alive to tell the story because the structures are too old. And find, this beautiful photo album that he, tucks away somewhere precious in his home, that he opened up to us, that probably no one in the world knew it existed until we communicated with him. So there are some treasures out there, and you just have to dig deeper. And like you said, it becomes harder the older the structure is, because there's no documentation to do that. Yeah.
And David, this is also, I mean, I want to make an announcement. If anyone wants to jump at some point, you can just unmute and talk.
I also have a question for you. But just go ahead, and then I'll
of course.
ask.
No, I think so. It's staying in the theme of teaching and learning. There, I mean, in the course that you talked about, Maria, they had model making. They had modeled also digitally and physically all these structures, and I think this is really fantastic. But also, I mean, the actual technique was also practice, and I could see that in your case, David, when you led so many workshops with students and in educational institutions to actually make things by their hands. Is the frequency of these courses to your liking, in the sense that do you think we need to have more of these activities? Because they always looked at as is this design build, for example, coming from an architectural school, it's a discipline, it's a design build project that should happen at some point in the curriculum, and that's it. But I really think there's more to this activity that we can highlight.
I think these workshops are really good for students. They learn a lot, and they always are very thankful for them. And many of them say, well, this is the first time I touch a mortar. Or you ask at the beginning, how do you know how to make mortar? And say, what? And I mean, they learn a lot by lifting and knowing how much things weigh and how hard they get when they are when the mortar gets hard, and how, you know, all these things that they learn, they are great. The timing, the how to organize themselves in the site, they learn a lot. But if it's true that it's a lot of effort from the teachers to be there to, I mean. So yeah, I always say that I will do these workshops less frequently, but then I said, well, yeah, why not? Because as you said, also normally research is an excuse to do one workshop, and a workshop is an excuse to do more research, and then I just get excited with a new little thing that I try to introduce. Of course, you cannot introduce big things that you try, because then you also need to have some kind of nice outcome, not because you want to hang the picture in LinkedIn, but because the students deserve some happy ending at the end. So yeah, I kind of introduce little stuff so that it becomes also interesting for us, for the teachers, because it is true that it's a lot of work to look for well, budget, sponsors, the everything, a new shape, a new thing. But I think I see kind of necessary for them to at least once do any kind of building activity with their hands, at least once in the whole studies of architecture in this case. But I guess also for engineering, it's also a good experience. Yeah. So if I am allowed, I would like to ask you a question. Yeah, because I love your work. I think you do amazing stuff, and one of the things that I also find very interesting, and I think it's a step forward, because it's not done normally. It's this prefabrication of a tile vault. So you said it's because of the time that you had to build it, but I think that was great that it happened, because I guess it allowed you to explore this new facet of building tile vaults. And I thought about that in other cases, just to try to prefabricate it, to bring it in pieces. But then I see, yeah, there's many little problems that I think that could arise, and maybe you can explain them. Problems that if you see the outcome that we saw in this Fabricarte, no, in this exposition, it came out really well. But I guess I also thought that maybe these pieces could have some how do you say, some grietas, sorry, the English word, cracks, yeah, sorry. So that they could crack. That maybe the interlocking is also difficult. So did you prefabricate 1 or 2 layer vaults, and then you put the third one on top, or is it like that? Or and did you put in the interlocking, so maybe you had some layer that was out more than the other one so they could interlock, or did you put mortar in between or concrete, or so?
Yeah.
Could you explain a bit further to learn about it?
This fantastic question. So first, I think because we cut it and we assemble it, it's somewhat we used plaster for the same for joining him. We did only one layer of fabrication. Then we added more layer with mortar, of course, on the top and on the bottom, which is something that, again, when we think about tile vaulting, there's also this pride about it's the first layer that should stay. I mean, you cannot add a layer underneath. And this was a challenge also to the convention of how you build a tile vault.
That's so Westapino's, no? Westapino's.
Yes. It's quite identical to without the very neat mortar. Of course, we couldn't do as the one you see in Westapino's. But yeah, so it is like that, and we designed the cut so that there is some sense of interlocking between the edge arches and the whip in the middle. So it's always kind of receiving it in a different heights and different. So the cut itself, some of them were straight, some of them had some kind of angles in them. So that's how we sorted out. But I think the main issue in this one was it was only one layer. If it was building the 3 layers together and then assembling it in a system, I think we would have a very huge limitation to how we prefabricate these structures. On that, I think there is a continuation of this research that I didn't show, where you cast mortar in the joint. So you join them through a cast of a very limited formwork for where the joints are, and you cast mortar there. So doesn't have to be perfect, and just the mortar itself starts to join it all together. But I didn't try that on a large scale yet. So I think
that's what you presented in IASS.
Yes.
I think I read that paper, but that's not what you use in Fabricarte.
No, in
that's
Fabricante,
different thing. Okay.
Yeah, it's a different way. It's doing cutting and then re-gluing with some patterning in it, so that it doesn't have any crack, and then of course adding the layers on the top on the bottom. We have some questions. So first is from we have a question about a very practical one, but I think it's really useful. Is there some info about the use or manuals of RhinoVault software? I think Oban or David, you can talk about this, since you're both were in block research.
There's a great website for RhinoVault too, with tutorials and examples. So I can drop the link in the chat. There's been a lot of work to actually make it accessible.
Excellent. And we have another question. Wonder how difficult it is to train non-skilled masons to master the tile vaulting technique. Anyone wants to? So
well, I think it also depends on how much they want. So for me, I had experience of some people who were not at all interested in this, and that was really difficult. And even more if you're trying to build freeform vaults, which are not straightforward at all. So, for example, we had some masons that were a bit like shocked that they already knew how to build a tile vault, but they never faced a freeform one. So they were like, oh my God, this is so difficult. So they really started like, I cannot do this, or this is just crazy. I don't like it. So like in everything, it depends a lot on what it's your mood to do it. And even if you are an expert mason or not. And if you are not an expert mason, of course you need to pay attention. You need more time to teach. But I have had excellent experiences with students who just grab a trowel for the first time, and they were really good doing this. So, I
What
mean,
Makes me think of
contributed to the build of the vault you show. I know you. I mean, we've seen you in the pictures with the trowel in your hand. Maybe you can also talk about this. Roban?
Roban, yeah.
Yeah.
also, sorry, I mean, I was going to say that makes me think also of what's a craft technology or digital craft, the same way that with Salvador we had to have introducing not to maybe more complex design, but a different technology of a headset. And there's also the mindset of a person who's willing to learn or not. With Salvador, was great. But I can imagine that with others could have been more challenging, or we need to have more pedagogy, or maybe start with something a bit more simple. But with Salvador, we actually did first like a very shallow vault, like if it was 1 by 2 meters, very shallow, low complexity to actually do it step by step. So I can imagine that. And I was in the other position. I was learning about thin tile vaulting, and I was already convinced, but had no skills about that. But I was in the mindset of actually learning, so I think that always makes it easier.
Yeah. If I can say one thing about that is the learning the technique is quite fast. I mean, you can learn how to mix your plaster and put it to the tile and put the tile in its position. But this exact, like many other ways of building, it actually comes about solving problems all the time. There's always a problem and you need to solve it. And with experience, you face many problems so that you get more and more experience in how to be faster, how to work more efficiently. For example, one thing that I find really fascinating also in the construction is that they prepare the tiles, they prepare the mortar, and they prepare the trowels. It's like really setting it's like installing softwares for when one wants to design. They do all their tools near them so that they don't have to walk to bring a brick from 3 meters to put it. So there's always this kind of establishing a rhythm for construction that is not interrupted and it goes smoothly. And I think that takes more time, and it comes with more practice and with more observation, being alongside someone who's building this thing, while being with people who are building these vaults. Every time you spend more, you understand why they do things like that and why they do things in a specific way. And that's what takes time. But the learning of the technique can be done within days, if weeks, if not days. But then after that, it needs the support of someone who knows a lot about this and can only be there for specific questions.
Yeah, I think related to that and the role of an architect working with experienced masons or non-experienced masons is also that you can rely on experienced mason, and then you can at some point you can say, okay, I'm going for a coffee, and then you are sure that it's going to be fine. But if they are non-experienced workers, then these problems are going to happen all the time. So you need to be there to really try to solve them. Yeah. So it's all about then solving these little things, or not that little, but many things that come up.
Right. We'll move to another question. Maybe maybe that's going to be our last question. It's from Firas Hawasli. In the application presented today, the vaults are mostly standalone structure. What is preventing the inclusion of vaulting in hybrid structure? For example, flatter vaults in timber multi-story buildings. And I know some of the research that there may be some of these instances already on your research that you're doing.
Hybrid structures, but then he says,
for instance,
with timber. Okay.
Yeah, flatter vaults in timber multi-story buildings. So it's kind of a replacement of a concrete slab where we use vaulted structures in general. Yeah,
well, timber deflections could be a problem. well, but also depends on the section of the timber, of course. But there are many examples in ancient buildings that are not like big tile vaults, but there are little tile vaults in between the wooden or the timber beams. So these hybrid structures, they already exist, and they exist in the past. And it's something that it was not shown today, but I just show it's not shown today, but there are many examples combining tile vaults with concrete. Not a lot, but some of them. And I showed only one picture of these patterns by the Guastavinos where they tried to do that, or they already started to mix tile vault with concrete, tile vault with reinforcement. And there are other engineers and architects that have tried that for example, for a water reservoir, for a church. There are examples that, yeah, it's in the literature. So yeah, I've written a paper exactly about that because it's in my PhD thesis, and there's also some work done in Cambridge about reinforcement of tile vaults in the middle layer with geogrid, and so there are some examples of it.
All right. I'd like to. I'm not going to say anything. Does anyone want to add any things or any thoughts or?
I don't know if we have time for one question. I have one, which would be maybe for David again. So, do you have examples where, when you move from design to construction with the builders, where you had to change the design, the system, the material, anything, whether it was like fixing something or improving something, but something that happened post-design with the builders?
There is because I normally don't want to stand a lot in the Bricktopia project, which is this first vault that I showed that we built. That's the free-form one, the bigger one. The design of that one was different at the beginning, and we had to change it because of time constraints and budget constraints right in the middle of the work. So yeah, we had to change completely the design. Well, at half of the vault, we had to change how it finished, and that's one of the samples. And then yeah, it's a bit difficult because the shape needs to be exactly a shape that works. So you need to reimagine a shape that still is the same one as before, but in a different shape. And then you have to explain the workers why, how, and so on. So it's not easy, but I'm not sure if I understood your question. Is how you can tell the workers or how?
Yeah, I think that happened like through discussion on the construction side. I don't know if there's like fixing a tessellation thing or improving a detail or that kind of stuff.
Yeah, for example, in Bricktopia, that was our first big experience with that. We did not have a very thorough plan of the tessellation, so it was a continuous discussion with the workers. So you were just following one line and say, should I follow this or the other one, and then how should we finish it? And then it was all the time like discussing this. If it should go this way and then start in this row, or you should start in the next row. So yeah, and it's that was my first big experience with a big construction of tile vault, and I learned so much with people who knew how to build it, because of course I could say how I wanted it to, or how we, because it was not only me, we were a team, but we could discuss with them how we wanted it to look like at the end. So we had that idea in mind, but then we had to listen what they proposed and what they said, because they were the ones that really knew what was going on with the brick and the construction, and this collaboration was in fact really, I don't know, really really good. It was great and really didactic for us. Yeah.
All right. Thank you so much, all of you. I also wanted to mention one last point with Maria's presentation. I think recently there has been a little bit of partial collapses in the school of ballet in different locations, not in the main dome, of course, but in different locations. And I think it's been amazing to document and analyze the structure for a purpose of rehabilitation. Was there any? And I know and I'm aware that much of all these decisions is somewhat entangled with political and social and many other things that has to do with taking the decision actually to save these buildings, which I think that the 5 of them are amazing. But are there any kind of progress towards any initiatives towards their rehabilitation, or is it something that it's going slower or slowly?
Yes, it's going slowly or slower. I haven't heard of a big push, but the studies that we did along with our colleagues in Italy are intended to accelerate that, to indicate, what is happening. The partial or the differential settlements between supports is a big problem. That is, it could be the cause of the partial collapses, things that you're seeing. But but overall, we're hoping that our project will accelerate that process and give everybody confidence.
I hope that too. Well, thank you very much, all of you, Maria, David, Roman, for this really amazing panel. I mean, we can go for more time, but I think that's what we have. We have only 2 hours. So thank you so much for your time. Thank you so much for being here. And thank you, Virginia, and the team of Digital Futures for hosting us. It's been really great. Thank you.
Yes, thank you so much to everyone on the panel. Please remember this video is recorded, so you can watch it again and again and share it with your friends. We have upcoming events always posted on our social media, so please check for those events. And during the month of June, we will be having some summer festival and workshops and conference. And during the month of July, we will have online workshops as well. So please continue to follow for our future events and educational opportunities. And thank you so much again to Wesam and everyone who shared their wonderful work today. Have a wonderful day. Bye-bye.
Thank you.